Good afternoon to all. Am I audible?
Good afternoon, sir.
Yeah, it's audible now completely.
Yes, sir.
Let's wait for 2 minutes. Any doubts you can ask right now. Okay. Okay, people will be attending offline classes now after this week, I think. Next week.
Sir, classes will be also offline.
No,
Only
no,
labs.
sir. We got that information that we will be attending only lab classes offline, and that theory classes will be normal as per schedule.
Okay.
Online classes, normal online classes.
Okay.
So, if you got anything new, sir, tell us.
Nothing new. Okay, so let's start now. So we were talking of the load characteristics. So in that we learned that the load is essentially the torque developed by the motor is essentially used up in overcoming. Okay, so the second. Okay, so the torque developed by motor, say call it Tm, is actually used to have the load torque overcome the load torque. Then it is used to overcome the friction and windage losses, and then some part will be used to accelerate, right, or deaccelerate. So these are the three main components which we will be seeing in details now. First of all, we will be seeing what is this. This is comprised of three components. We will see to it right now. Then we will focus on the load torque, what type of load torque is there, and then we will finally have the equations. So again, this window has come up. Okay, so let's go to the next. Problem is there with this window every time. Just a second, let me check out if I can solve the thing. Maybe no way. To seek to an expert. Okay. So this windage and friction losses is comprising of some viscous friction. So this is the viscous friction. This is the Coulomb's friction, and some part is the stiction. So that is stiction means static friction, right? So stiction is made up of two words, static and then friction. So static friction. So let's see what are the graphs of all these things. Viscous friction, I hope you understand. Just a second. Yeah. So yeah. So stiction is somewhat constant. So actually this is the stiction TC. So this is the stiction force. This is the viscous force standing for TV. Sorry, that is the Coulomb force. That is the Coulomb. This is the stiction. This is the stiction. Stiction. Friction from static friction, it comes up as stiction. So the net resultant of this will give you a graph of this. So what is this TV curve? TV is the viscous force, which is directly proportional to the velocity of the wind it is passing through, right? Just like if you drive a bike at a higher speed, you will experience a higher drag force, right? Is it not so?
Yes.
So the more speedier you drive, the more is the force, right? So it is directly proportional. So that is why this line is very much straight. Say this line is absolutely straight. And then you have something called as Coulomb friction. So that is the force due to the intermolecular forces of attraction between two surfaces. So it gives rise to Coulomb forces, and hence a torque is produced. So that is always constant. And last of all, we have got stiction. So stiction, the graph is something like this. So initially it is there, and then the graph goes on to like this. And the net resultant of these three curves add up to this one on the left side. So TFW is windage and friction losses. So viscous, Coulomb, and stiction. So this is the individually that is coming up. So this is the means this one is the viscous friction. Viscous friction. The second one is the, did I make a mistake? Yeah, I was of
Yes,
this
sir, you made a
opinion only.
mistake.
Yes, that's why I was thinking what is happening. What I learned and what I'm presenting is different. So Coulomb friction is this one, this smaller one, right? And this is the stiction. Stiction is always a constant, static friction, because friction is there now. So friction will be obviously there, else how can you move, right? So this static friction is constant. It is of a constant value. Yeah, now everything fits into place. Yes. Okay. So then the motor torque is equals to load torque is equals to steady state torque plus transient torque plus mechanical losses. So do you understand this much at least? Whatever the torque the motor is producing, what is, say this is the motor. So what is it going for, all the torque that it is produced? First of all, it is going for the overcoming the steady state load torque, right? Say it has to move a lift up and down, right? So it will have some steady state load torque, and then the lift actually has to start from zero to some speed, right? So then a transient torque is there, so that too it has to be taken care of. And finally the mechanical losses. Mechanical losses means the three forces TFW, that is the viscous, then what, Coulomb, and stiction. C, I think stiction. That is static friction. So using the three things, the viscous, the Coulomb, and the stiction, it becomes the mechanical. And there are some windage losses also. So what is windage losses? Windage losses. See, the total mechanical losses will comprise of two things. Can you tell me what the total mechanical losses? The total mechanical losses will consist of two items. One is the
Friction loss and windows loss.
friction. So where is the friction? In the ball bearing, right? And then in the windage losses. Windage losses will be comprised of three items. So that is Coulomb forces, then viscous, and then stiction. STCIM, stiction. So you must remember this. This will come in the short questions most probably. Okay. So if we have the equation, we will not go to the equations right now. Right. So I will just spend some time classifying different types of load torque that you can see almost everywhere. Then you have the graphs on the left side, you have this A type of thing as constant load torque. So this is what type of characteristics it comes from? It comes from winch drive, crane hoisting, conveyor, piston pump under constant pressure. So do you see this thing at least in the shopping malls? Conveyor? Do you see these things? Conveyor? You will not see a conveyor type of thing, but you will see similar type of things in the staircases that keep on rising up.
Escalator,
And
escalator.
yes, escalators. So something like that, you have a conveyor belt in the in the coal-fired plants. They keep on delivering the coal dust from one point to the another. So the type of load that is associated is like a constant load torque, almost constant load torque. And then you have compressor type of load. We are actually studying various types of mechanical loads, which when connected to a motor has to be considered, right? Then compressor type of loads is of B type, where you can see it, how is the graph, and then constant power load. So constant power load means power equals to torque into what? What is the equation for power? Mechanical power, at least on the mechanical side. What is the equation? Power equals to torque into speed, right? Have you forgotten this? Power is equals to torque into speed, right? And anyone having any argument for this? Okay, so how is the power constant here on the graph C? If you see this graph, this one, you will have this power equals to torque into omega. So see, if the torque is at this point A, the speed is, sorry, if the torque is T1 and the speed is S1, say. Now if you increase the torque, the speed will obviously decrease. So don't you think this, if the torque is increasing, the speed is decreasing and vice versa? Yeah,
Yes,
please.
sir.
Yeah. So that is why this power is constant. Power is constant for this. So what types of things has this type of characteristics? A winder, a transportation. Doesn't it happen in the transportation sector? Then lathe, boring machine, and rolling mill, paper mill. So just tell me a point where this transportation thing shows this type of graph. Where does the transportation thing show this type of graph? Say any type of electric vehicle or any type of vehicle also. Say if one person is sitting, don't you feel that you can go to higher speeds?
Yes, sir.
And when 2-3 persons are sitting, can you pick that much of speed at
No,
the
sir.
same accelerator point? Then you have to pump more of the petrol, right? You have to
Yes, sir.
press your accelerator or go for more acceleration. Then only you can attain that same speed. So the more the weight, the lesser is the speed. That means the more is the demand for the load torque, then lesser is the speed with which you can drive. Then comes fan load torque. So that is the most common example of a fan load
Sir,
torque, that is your ceiling fan.
sir, the two graphs you have shown, which one was for whose?
Yeah, it is written, see it. Graph A is for constant load torque.
Acha.
The torque will remain constant all over the time. This example is a conveyor.
Okay. Compressor load torque.
Compressor load torque is the right one, graph B.
Yes,
And the
sir.
constant load power load is graph C, where you find that if, how do you say that it is a constant power load? How do you say it? The
Torque
power
into
is equals to torque into omega, right? So if the power has to be constant, then what? If the torque increases, the speed should decrease,
Yes, sir.
and vice versa, right? So
Yes,
in
sir.
the
Yes.
graph, you see that if say this is the operating point A, then for this is the T1 and this is the speed S1. If you are going for higher torque, then see the speed is automatically decreased.
Sir,
So
compressor load torque, can you explain it a bit? Compressor
compressor
load.
load torque, um, say how do you fill up, how you used to fill up the tires of your cycle?
Via that pump, sir.
Yeah, and
Okay.
no, not for that pump, using that mechanical type of that big cylinder used to
Oh,
be
yeah,
there.
yes, sir.
Yes,
That
and used to just pump
motor
in.
driven. Yes, sir. Motor
Yes,
driven.
motor driven, right? So what do you find that thing to be? As the pump, as the cylinder becomes full of air, then what? Then the motor has to pump more and more energy to fill that little space which is left out. See, usually when the a tank is empty, it is very easy to pump the air in, right?
Oh, yes, sir.
It's just like inflating a balloon,
Yes, sir.
right? So if you find that, the torque will be of nature B. So the more it gets filled up, the more torque it has to be applied to. Hope you got it. Now using the fan load torque. So fan load torque, please remember it. It's very interesting to see that the torque is dependent upon the speed square. See, the torque is dependent upon the speed, that is omega square, and power is what? T into omega. So T is proportional to omega square and into omega. So power is proportional to omega cube. Just think of it. So if you have a ratio P1 by P2 is equals to omega 1 by omega 2 whole cube, just think about it. If you double the speed, what will happen to the power? If you double the speed, what will happen to the power?
It
Is
will
it a
be 8
linear
times.
relationship? Is it
8
a
times.
is it a relay? Is it a linear relationship?
No, sir.
No, right? So just find it out that the torque is proportional to omega square, whereas the power is proportional to omega cube, right? So please remember this, and that torque graph will be of this nature. So only of the first nature. So it will be of this nature only. Right. So power is proportional to omega cube and torque is proportional to omega square. And what about the next one? So that is called an ohmic load. So that is called somewhat ohmic load. Why? Because it's a linear. See, the torque is proportional to the torque. Sorry, the torque is proportional to speed only. It's a linear thing, linear. Right. So it is called as, say, a generator is there and the generator is connected to a bulb. So what is that bulb like? That incandescent bulb is a ohmic load, no? That's a linear load having a filament, right? Or a heater also. So if you have a heater or some type of incandescent bulbs connected, that is a resistive load is connected to a generator, then it produces an ohmic, uh, a linear load. So load torque is proportional to speed, something like this. I hope it is okay.
Yes, sir.
Now there is a big classification on the type of load, right? That's called a passive load and active load. So what is passive load? Passive load is like it always opposes the motor and changes the sign whenever the motor changes the rotational direction. For example, have you ever dipped your hand inside the water and tried to move?
Yes, sir.
what happens if you go forward? The water tries to resist your motion, right?
Yes, sir.
And
Both
if
sides.
you, yes, both sides, that is the thing. So it always opposes you, right? It always opposes you. It always opposes the motion of the motor, right? And changes the sign whenever the motion is reversing. Is it not so? If you place your hand into the water, try to move forward, it will oppose. If you want to move it backward, again it will oppose, right? So that's
Yes, sir.
called a passive load. So example, for example, this is one such example. See, is this not a good example? It's a cutting tool. So if you cut on anti-clockwise also, or for the clockwise also, it will always oppose. Is it not so? Can you see the
Yes, sir.
animation?
Yes, sir.
Yeah. So that's called, so this cutting is happening because of friction only. Na? So ultimately, this is the thing that it will oppose in whichever direction you move, and it will change whenever the motion direction changes, right? Now we go to active load. So what is active load? So when you are coming upstairs, do you feel that opposition due to gravity? Is it not so?
Yes, sir.
And when you move down, do you feel that opposition due to gravity?
No.
Then what happens? The gravity tends to drive you, right?
Yes, sir.
That's the thing. So it has the potential to drive the motor from an equilibrium condition. That is, if the lift is, say, in the third floor, right, and the motor is there connected to it, and suddenly the power goes off and there are no emergency brakes. So what will happen? The lift will come down, right? The lift will come down if there are no emergency brakes, right? Yeah, give me a feedback.
Yes, sir.
Yeah. So what's it's like? It's due to gravity. So gravity is an active load. So it's called gravitational force, tension, compression, torsion. So, so this is one such example which I took out. So it's like the compression force of a spring. It's the, the main thing is that whenever the load torque is changing, it will not change its sign. That is, for example of a gravity, you can feel that when you're climbing upstairs, you'll feel that there is a opposing force. But when you are going downwards, do you feel that there is an opposing force? No,
No, sir.
right? So that is, the gravity does not change its direction when you climb downstairs, right? Another such example is this weightlifting. That's a gravitational force, right? So when you go up, you feel that thing, you feel the opposition. When you go down, do you still feel that opposition? No. So that's called an active load. So official definition is in this slide only. I will be posting this slide shortly. Right. Okay. So what is equilibrium and steady state stability? Do we have time? Okay, 20 minutes left. Equilibrium speed of a motor is obtained when motor equals load torque. When does it happen? When can you see this to be happening? This one. When does it happen?
NS is equal to NR.
No, no, no. That is something from the motor side. Say when you are driving a vehicle and your vehicle is running at a constant speed. That means what? You are not accelerating. You are not accelerating, right?
Yes, sir.
So that means what? If you're not accelerating, then the total generated torque, developed torque by the motor is just equals to the required torque. That is the load torque plus all the mechanical losses, the windage and friction losses, all the things, it is just become equal to that. Don't you feel so? See, if you have two forces, equal forces on 180-degree apart, then what will happen? It will be at rest or at constant motion, constant speed. So similarly, when the torque is at the developed torque is equals to the required torque, then a constant speed comes up. So that is called a steady state stability. So the motor load system is considered to be stable in steady state if the equilibrium is stable. So it is obtained from the speed torque curve. So let us see how this is happening. Sorry for the presentation. This window is still
Sir,
disturbing me a lot.
the developed torque should be equal to either motor torque or either load torque, because motor
Who
torque
is
and
developing the torque? Who is developing the torque?
motor.
Developed torque is developed by the motor, no? So it is Tm or
Yeah.
Tg, whatever it is. Developed torque is developed by the prime mover, right? In an electric vehicle, the prime mover is the electric motor, right? In any other application where an electric motor is there, so that is the prime mover.
Yes, sir.
So when the developed torque is equals to, say here we will use the term say T, right? Say we will use the term T. When it is equal to the load torque, then equilibrium state is obtained. Now here it is a very important area, after which we will be ending the class. So here it's very important to understand what is this graph look like, why we are taking help of this graph. In the graph, if you see properly, a torque is on the x-axis and the speed is on the y-axis, right? Now, this is the load torque and this is the generated torque, right? And we are at point A, say, and the vehicle is running at constant speed. Now, what happens? There is some disturbance in the speed. There is some disturbance in the load torque, say. Say the load torque, say you are carrying a heavy battery and it fell down, right? So what happened? The load torque decreased. Is it not so? The load torque on the engine decreased. Is it so or not?
Sir, come again, sir. I didn't understand what are you trying.
Say you are traveling in an electric bike with a heavy battery, 20 kilo battery, right?
Yes, sir.
And that 20 kilo battery was just a simple any other type of battery. It was not the core battery of the vehicle, right? So that was a solar battery you were carrying to your home, and suddenly that battery fell down, right? So if the battery falls down, your total weight that you are sitting on the vehicle comes down or not.
Yes, sir.
So the load torque on the electric motor will go down, right?
Yes. But if the battery falls down, sir, how the motor will run?
It's not the main battery. It's just a big weight. Okay, say
Also,
50 kg
just a
rice.
normal weight. You are saying normal.
You feel that it's a 50 kg rice bag, right?
Okay. It fell down. Okay.
Yes, it fell down. So what would happen? The load torque would decrease,
Yes, sir.
right? If the load torque would decrease, then we have to see what happens. Or in other words, vice versa, if there is a decrease in the speed, if there is a decrease in the speed, say the speed goes down, then what happens? This point is the TL, and this point is the TG new, and this is a TL new. Is it not so?
Yes, sir.
So which is greater? TG new is greater than TL new.
Yes, sir.
So if the generated torque is greater than the load torque, what will happen? Acceleration or deceleration?
Acceleration.
Yes. So it will accelerate. Accelerate means the speed will increase or decrease?
Increase.
Yes. So the omega will increase and it will try to achieve this state again, right?
Yes, sir.
Again, go to the reverse one. Let's say the speed has now increased suddenly. The speed has now increased suddenly, right? So what is the new value? Say it has now reached this point.
Sir, but according to the concept, sir, if load falls down, its speed should increase because because of acceleration.
So
Huh?
we are taking this case, na? We are taking this case. We are taking this case. No. Say we are a bit confused. So
Yes, sir.
uh, just listen to this now. Forget everything else. Then we can connect independently. Okay. I'm drawing it again. Say due to some changes in the voltages of the motor that are running in the factories. So this is the torque, right? And what is the speed? So this is the speed. So the graph is like this. This is the point A, this is the point of equilibrium, right? And this is the load torque, and this is a generated torque. Now, say due to any reason, say suppose the voltage of the system has decreased, right? Or say it's the reverse case, it has increased, the voltage is increased, say. So the speed wants to go up, right? If the speed wants to go up, say this is the new speed, delta omega m 1. Then what will be new values of Tg and TL? This will be the value of Tg new, and this will be the value of TL new. Is it not so?
Yes, sir.
So which one is greater?
TL.
TL is greater, so what will happen? Deacceleration or acceleration? Load torque is
DX.
greater. So deacceleration. So it will speed down, the speed will decrease, right? And it will try to achieve to the, it will try to go to point A, right? Similarly, due to some voltage fluctuations, say the speed goes down, right? The speed goes down. So the new values would be what? The new values would be, this would be the point of what? TL new. And this would be the point of TG. So which one is greater, TG new or TL new? I think things are getting messed up, so I will better go to paint. That will keep it clearer. So please wait some seconds. There are very few options to make in this PPT.
It's actually clear, sir. No need to paint now.
No, there are some. Okay. Okay, so this is the torque and this is the speed omega, right? And we have the graph of, so what was this? T load, and this one is T generated, and the equilibrium point is in the middle, this one, point A. So say we are going down on the speed, so the speed gets reduced here. So this is the new speed, omega 1. So what is the new value of TL? This is the TL new, right? And what is the new value for TG? This is the TG new. So which one is greater? TG new is greater.
Yes, sir.
So what will happen? Acceleration. So the speed will bounce back to its original equilibrium point, that is point A, right? And similarly, if we have some voltage issues and the voltage is shooting up, then the speed will rise up. say omega 2. So owing to this, what will be the values of new speeds and new torque values? This will be Tg new, the pink one, and this will be the value for TL new. Which one is greater?
Sir, TL.
TL is greater than Tg new,
TG.
right? So
Yes.
what will happen?
Sir, retardation. Deceleration.
Yes, deceleration. At the speed will go down, right? And if the speed goes down, it will try to achieve again this speed. So is the system stable? It's trying to return to a main point of operation.
Yes,
That is
sir.
the point A, right?
Yes, sir.
So the
Yes, sir.
system is stable, right? So similarly, we will observe with the reversed case. So what will happen if this is not so? Let's see it, very interesting. It took some time for me to understand in my days, but it was very interesting. So if this is the chart and we have the right side as torque, the y-axis as the speed, and we have this one, and so the right side was TL, right? So here we will know the TG part. So TG is on the right side now, and TL is on the left side, right? And what is the equilibrium point? Say this is the point B. Now you tell me what will happen if there is a slight change in the speed. This is the steady state speed.
So totally opposite of first cases.
Yes, so say the voltage is a bit down now. So the speed is gone down. So this is the new value of
Generated torque.
TG, and this will be the new value of
TL.
TL. So which one is greater?
Sir, TL is greater than TG.
Yes, so TL is greater than TG. That means what? Acceleration or deceleration?
Deceleration.
Deceleration. So what does it mean? The speed will go up or go down?
Go down, sir.
Go down. So that means it will go down further. The same
Yes,
thing
sir.
will repeat, and finally it will become steady. It will reach zero state. That means the vehicle will stop,
Yes, sir.
right? And similarly, if the reverse happens, if the speed goes up a bit, then what will happen? This is the new value of TL, and this is the new value of what? TG. So which one is greater?
TG.
TG is greater. So TG is greater than TL in this case. So what will happen? Acceleration. So the speed will go up higher.
Yes, sir.
It will again, the same case will repeat, and it will go up higher and higher till
Yes.
there is enough centrifugal force to tear apart things, right? Means it will reach an uncontrollably high speed,
Yes, sir.
right? So is the system stable?
No, sir.
It is unstable system. Any changes in the speed can trigger a big problem. So it's an unstable system, right? So do you now understand how do you get hold of this stable and unstable system?
Yes, sir.
Yes. So let me. Okay. So this is the way how to find out whether a system is stable or not. It will be asked. So is it an unstable
Sir,
system? Yes.
these changes in load, on which factors it is depending?
Load can change on any factor. The load torque, the speed can change on any factor. Say for example, the input voltage. Does the speed of your fan remain the same in the summer season, especially at the when there is a low voltage?
No, sir.
So there can be a multiple factors for which the speed can change, right?
Yes, sir.
Yes, sir.
That's the thing.
So suppose according to you, sir, voltage increasing or decreasing, sir, load should, I mean, its speed should increase, and if speed should speed is increasing, then
See, for your ceiling fan, the system is stable, right? So you won't find that instability. But there are certain applications where there will be instability. We'll come to that later. First of all, you understand the graph, then we will connect it to some applications. Is it so?
yes, sir.
Yeah. First of all, you understand the graph, that how it becomes unstable.
Sir, like a automatic stabilizer in case of voltage control.
No. Automatic stabilizer is a bit different thing. So I leave it to you how you decide on this thing. Say it's on the second quadrant. So second quadrant, if you just see it, just find it out yourself. I won't solve this thing. It's up to you, right? So you have to think about it, whether the system will be stable or unstable. Apply the same formula, just bring a change in the
Sir,
speed.
in the second case, sir, why it is being unstable? Suppose uh, will it
Because
not
there
come back to
is,
its equilibrium point?
see,
Equilibrium point.
when if the system jumps back to its equilibrium point, okay, so for example, just for an example, an analogous example, if you place say this bottle, so can you see this bottle?
Yes, sir.
So if I place this bottle and I try to move it, so does it fall down easily? Can you see this bottle in front of me?
Yes,
Yes,
sir.
sir.
So if you just do like this, does it not come back to its equilibrium position,
Yes, sir.
right? But if I keep this bottle like this, it's in equilibrium, right? First of all,
Yes, sir.
then a slight change in the equilibrium position will make it unstable.
Yes, sir.
It got filled up with water. Sorry, I will take some time to clear up. So don't you feel the systems might be something like this on the rotational side also? So this you
Okay, sir.
saw on the linear side, you saw this example on a linear scale, right? But same things can be happening on the rotational axis also.
Yes, sir.
So that is the thing. At initially the system may be at stable point, right, like the bottle. But what will happen if some disturbance will come, right? So that is the study here. So if the bottle was having the wider base at the bottom, even if you keep on disturbing it, it will bounce back to its original stable system, right? But the moment I make it on the reverse side, if I just even touch it, it becomes unstable, right? So do you feel that how this thing can be stable and unstable? Is it okay, or can I proceed?
Yes, sir.
So I leave it to you and expect these type of questions in the internal, right? So these are what stable or unstable systems we have to find out.
Sir, will
Yes,
you provide us the notes?
yes, I have already provided you the notes, not the not the PPTs, but the PDF of the thing, I think. Have you got it?
I
I
mean
have
the
already uploaded it in the contents section.
सर इससे पहले वाले पेज में जाइए ना.
This one.
Yes, sir.
Tell me whether the system is stable or not. So I think Somaya was asking about the notes. Please find it in the content section, right?
Sir,
Yes.
so in the both the graphs, sir, I've noticed that if TL is greater than TG, it should be deceleration. And you are telling that in the first case that it will come back to its original place A.
Because
So
whenever
why
the
it not?
speed will reduce, what you should do? You should have an accelerator point, right?
Yes, sir.
Say for just a simple example. If you are driving uphill, your speed will reduce,
Yes, sir.
right? So if you do not press on the accelerator, what will happen?
Finally it will stop.
Finally it will stop, right? And when you are going downhill, if you do not press on the brakes, what will happen? It will
It will
go to
get infinite.
you will go to uncontrollable speeds.
Yes, sir.
Do you get a sense of it?
Yes, sir.
Yeah.
So, but here, how do I relate it? I mean,
Find one application and relate it, because we are studying electric drives, not specifically electric vehicles. So you have to find one application and just connect to it. Find one stable application.
Sir, can I
Find one
say,
stable application. Yes, tell.
sir, first one is stable and second one is unstable.
Oh, okay, for this one. Okay. So I
तो
won't
वो तो
comment
सर
on
पता
this.
ही है.
I'd be putting such types of questions in the internal one. So I'm leaving some things for you to think about it. Right? I have told you, whenever you want to have a stable system, immediately as soon as the speed goes down, you should have an accelerating torque, right? In order to regain back that original speed. And if you are going more than the equilibrium speed, you should have a deaccelerating torque so as to regain back to the speed, right? So you should bounce back to the equilibrium position. Then
हाँ
only
तो
your
सर वो
system
तो
will.
यहाँ पे केस बी में कैसे हो रहा है सर, वही तो नहीं समझ आ रहा ना सर. जैसे यहाँ पे पहले केस में TG इज लेस देन TL.
So which one?
इसमें
Which one?
सर केस बी में है जो जहाँ इक्विलिब्रियम पॉइंट बी है जो बी.
This one?
हाँ. Yes sir.
Find out. So if you are going down, so I have that window outside. Say for example, this is the facing difficulty. Okay, let me go to the paint section. Wait. Yeah. So just think of it.
सर यहाँ
So
पे देखिए सर.
initially this is the steady state speed, WSS, right?
Yes sir.
WSS is the steady state speed. Now there is some problem due to which the speed is going
Increasing.
down, right?
Yes sir.
Say it is going down, first case.
Yes sir.
Then in order for the system to be stable, it should bounce back.
Yes sir.
Then see, for the new speed, say this is omega 1, what is happening? If you draw the lines on the two lines, on the two violet
Yes
and blue
sir.
lines,
Yes sir.
you get this TG
Mm-hmm.
and you
Yes
get the TL. Now on the x-axis you have the torque. So which one is greater? Sorry,
TL
I'm
is greater.
mistaken. Yeah, TL is greater, right? So TL is greater than TG. So what will happen? Acceleration or deceleration?
Deceleration.
Deceleration, right? So
And it will
deceleration
finally
means
stop.
it will go down further.
Finally stop. It will.
If you again draw the lines, the same condition will be there. It will finally stop, right?
Yes sir.
And in the same case, go upwards. Same case, go upwards. Say this is the new speed omega 2. This is a speed. So what is this one? TL, right? So this is TL and TL new. And this is the what? TG. So which one is higher? Which one is higher in this case?
TG
TG is
higher.
greater than TL. So what? Accelerating torque? If TG is greater, it will accelerate.
Yes
So it will keep on accelerating. It will keep dangerous high speed, after
Yes, sir.
which you don't know what will happen to that thing then, right? So that is why this system is unstable. So do you get
Yes,
it now?
Yes sir, I got it now.
Yes. I think the time is up, so I won't be able to carry forward. Okay, so meet you in the next class. I don't know when is the next class. I think so. Tomorrow we have the next class, right? 12 to 12:50. I think yes. I'm afraid that I won't be able to take the next class because of some issues. So if in case I happen to miss it out, I'll be taking it from um, Friday on Saturday, right? On Saturday, because Friday you don't have any class. Okay, so for now there are no announcements. So just download the video and you can again see to it. Okay, any doubts for now?
No, sir.
Yes, sir.
Yeah, tell me.
Sir, can you give me more example of active load?
Active load.
Yes, sir.
Active load. See, gravity is one such active load. Then spring is there. So spring, if you just press on a spring, what will happen? If you just press on a spring, what will happen?
Sir,
It will give you an opposition.
yes, sir.
So, but if you just go upwards, will you give it an so will it give you an opposition?
No, sir.
No. So it will not reverse its direction. If you reverse the motion, will it reverse?
Sir, in case of pressing, yes. In case of
Say forget everything. Just you try to stand up and sit down. You try to stand up and sit down. What will happen when you're trying to stand up? Gravity is trying to oppose.
opposite. Yes, sir.
But when you are trying to sit down, is gravity still trying to oppose?
No, sir.
That's the thing. So its direction is not reversing as per your direction of movement.
But sir, in case of our applications, sir, like electrical way, mein,
What?
sir,
Electrical. Find out. Find it out yourself. Say in case of a spring, if you just press it, it will try to oppose you. But if you try to relax, will you try to oppose?
no, sir.
No. Then there are many examples. Just find it out yourself. So one such big example is gravity. Gravity is the biggest active load example, and so due to this, so gravity has the power to make a motor move from its equilibrium position, right? Example: if the lift is there on the fourth floor, and if there are no emergency brakes and the power has gone out, what will happen? The lift will
Fall down, sir.
try to fall down and it will rotate the motor itself. So
Yes.
does it not have the power to rotate the motor from equilibrium position? Active load.
Yes.
But for the passive load, think about, if you
Sir,
drive your vehicle forwards or backwards, it will obviously have a
opposite.
drag force on you, right? It will try
Yes.
to oppose your motion, just like friction, viscous friction, any other sorts of friction. It will always try to oppose you. So that's why it is a passive load. It will always change its direction when your direction of movement changes, right?
Okay, sir.
If find out more examples, the biggest example I have told you, right? Okay, so should we go for a flipped class in some 1 or 2 weeks?
What, sir?
Yeah, Milan, you will be receiving all the PPTs, don't worry. A load status, yes, you will receive, don't worry. Flipped classroom, where you will be taking a class, a presentation type.
Sir, when we will reach our college.
Yes, that's why I'm telling you will be having very high speed internet. So after 1 or 2 weeks, people can give a flipped classroom, right?
Okay, sir. Guys.
So it will be only for one class, don't worry. Every week it won't be there, but just 1 or 2 flipped classrooms are very interactive, right? So in the previous semester also we had one flipped classroom. Right? So that makes an interesting thing.
Okay, sir.
Okay, so meet you tomorrow, right?
Okay.